So we're going to prove this polynomial identity. The identity is called a sum of cubes. So if you ever start with this, this is its factored form. But we want to prove that that is true, that if you have this, this is how the factored form looks. To prove it, we need to change this side or this side, one of them, to look like the other. And if I look at that, I don't know how to change this. But I do know how to multiply these, and when I multiply them, I'll probably get that. So what I'm going to do is take the time to multiply this out and see if it matches this, and that would be a proof of the identity. So I'm going to use multiplication by FOIL, or a FOIL technique. You could also use a box technique. So what I'm going to do is I'm going to multiply these two. So x times x squared is x cubed. Then I multiply these two. That would be negative x squared a. And then multiply these would be positive x a squared. All right, now I'm going to multiply these two, which would be positive x squared a. I'm going to do these two, which would be negative x a squared. And I'm going to do these, which would be a cubed. And over here, I'm just going to keep what I have. I cannot touch this side. To do a proof, I don't want to change this. I want to only change one side and not change the other for this proof. So looking at this, okay, I might be there almost. Okay, well, they don't match yet, but don't things over here cancel out? When you combine like terms, don't you see pieces that they group and disappear? So watch this. Can you tell that this cancels out with this? Can you also see that this cancels out with that? And what you should quickly see is that is equal to all that's left, that, which is a proof. I proved to you that they're the same by only changing one side and doing that with legal mathematical operations. So we are going to prove this polynomial identity. So which side would we change to look like the other? Well, this would be very hard to change because you have to have some master factoring technique. But this side is pretty easy to change. We're just going to do some multiplication. Now, actually, instead of multiplying this out and using multiplication, you could also use binomial theorem. But I'm just going to multiply it out. Here we go. To multiply this out, what you have to realize is this is x minus y, x minus y, x minus y. So, to start off with, I'm just going to do one set and do FOIL. That would leave me x squared minus 2xy plus y squared. And then I'm going to rewrite the x minus y. So what I did here again is I have three of them. I did two of them real quick. I got this, and I have this still left over. So now I have to do another set of multiplication. I'll do a little box here this time. Okay, for this one I'm going to do a little box. All right, this would be x. This would be negative y. This is x squared minus 2xy and a positive y squared. Okay, so let's do this box. Let's see, x squared times x is x cubed. X squared times negative y is negative x squared y. Okay, x times negative 2xy is negative 2x squared y. This would be 2xy squared. Top right would be xy squared. And bottom right corner is negative y cubed. All right, so I did a little box. I did that out. Now, okay, does anything cancel out and disappear? What do I see here? What do I see here? Does anything disappear or combine? Does anything combine? Oh, I see some combining at least. Do you see these combining? Do you also hopefully see these combining? So what we have here is x cubed minus 3x squared y plus 2xy squared, I did it again, plus 3xy squared minus y cubed. So when you combine these, you get this. When you combine this, you get this. Now look right there. Does that match that? And yes, it does. Both sides match. So I have just proven the identity, the polynomial identity. And all I did was change this side. I didn't even touch this one. Again, you could have done this with binomial theorem as well.